Now, let's talk about types of aqueous solutions. Aqueous means dissolved in water. So water is the solvent there, just in case you're not sure about that. And then solubility. We'll talk about this in a lot more detail next semester, but so a solution can be classified as whether or not it's an electrolyte. So a strong electrolyte, does it break apart? Does the molecule break apart? In a strong electrolyte, yes, it does break apart, and there are many charged particles. So if there's many charged particles, do you think it conducts electricity? Heck yes. So example, this would be like salt water, hydrochloric acid. Maybe I'll do a demonstration of where I can conduct electricity using a pickle. We'll see. A weak electrolyte has some particles that are dissociated, but not as many. So it will conduct electricity, but it will not be as strong. So it will conduct some electricity, but not much. A lot of these are going to be like your organic acids, like vinegar. So that would be like acetic acid. A lot of organic compounds are weak electrolytes. And then you can also have a non-electrolyte, and it does not dissociate, it doesn't break apart, it dissolves as an intact single molecule. So it doesn't conduct electricity because there's no charged particles. So example here would be sugar. So C12H22O11, sugar, the table sugar. So I like to think about if you eat plain Cheerios and you sprinkle sugar on them, when you're done, there's usually like some sugar, like sweet milk. That's an example of that. Now, let's talk about solubility. These are solubility rules. They're more like guidelines, but we'll talk about solubility in a lot more detail next semester. But here's what you need to know. They're generally soluble if their positive, their cation, has lithium, sodium, potassium, or ammonia. No exceptions, we like that. Or if their anion is nitrate or acetate. No exceptions. If their anion is chloride, bromide, or iodide, it's soluble unless it's silver, mercury, or lead. It's kind of how you read this. Sulfates are soluble except strontium, barium, lead, silver, calcium. So everything but these three. Now, so those are the soluble. Yes, it's soluble. These are not soluble, so insoluble. These do not dissolve if they're hydroxides or sulfides, unless they're with one of the always soluble cations. Or sulfides are soluble with calcium, strontium, or barium. Hydroxide with calcium, strontium, or barium, it's slightly soluble. So I guess we could say, yes, it's soluble, but not very much. That's kind of a trick question. All right. Now, carbonate and phosphates are not soluble unless they're with an always soluble cation. That's how you read this chart. So let's try some. Okay, here I'm gonna write 4 compounds. All right, and let's circle the ones that are soluble. Lead chloride, is it soluble? Well, okay, so let's look here on here. There's a chloride. Chlorides are soluble unless it's paired with lead 2. That's lead 2, so not soluble. Copper 1 chloride. Chlorides are soluble unless it's paired with one of those. Yes, it's soluble. Calcium nitrate. Nitrates, always soluble, no exceptions. Barium sulfate. Sulfates. Yes, they're soluble unless they're with strontium, barium, lead, silver, or calcium. There's barium, not soluble. Let's try some more. Na3PO4, CaCO3, K2S, AlPO4, NaOH. All right, so sodium phosphate. Sodium's always soluble, no exceptions. Calcium carbonate. Calcium is not on the list. Carbonates, insoluble unless calcium's not one of them. K2S. Sulfides, not soluble unless they're with an always soluble cation. Aluminum phosphate. Phosphates, not soluble. Sodium hydroxide. Sodium is an always soluble.